In this video, we're going to do the last example in our handout for stoichiometry and the ideal gas law. So let's start off by reading the example. What volume of CO2 is produced when 5.5 grams of CH4 reacts with excess O2 at 35 degrees Celsius and 100 kPa? So let's start off by writing our balanced equation. We have CH4 gas is reacting with excess O2, which is good. That means we don't have to find a limiting reagent because we're told that O2 is the excess and CH4 is the limiting reagent as a result of that. And there's excess oxygen, so there's a lot of oxygen there, so it's going to be a complete combustion. CO2 plus H2O. And we need to have 4 H's, so let's do that. Put a 2 here, put a 1 here, put a 1 here. Now we're perfectly balanced. And we want to find the volume of CO2. And we know that if we have PV is equal to nRT, then the volume is going to be nRT over P. And so right now we have the pressure, which is equal to 100 kPa. We have the temperature, which is our, it's in degrees Celsius right now. We have to convert it by doing 273.15 plus 35. We have 308.15 Kelvin. And we also have the R value, which is the 8.314 kPa liters mole Kelvin. And so we need to plug all that in to find the volume. But the only thing we're really missing right now is the N of CO2. We don't have that currently. But we do have some information to help us find it. We have 5.5 grams of CH4. So we can find the moles of this CH4 here, and then use the mole ratio to find the carbon dioxide. So that's what we'll do next in our step 2. We're going to find the moles by remembering that moles is equal to the mass over the molar mass of that compound. Now, we're not using PV is equal to nRT, even though we have a gas here, because we don't have anything from PV is equal to nRT there for CH4. All we have is a mass, and the way to convert from mass to moles is by using this equation here. So we're going to have 5.5 grams over the molar mass of CH4. So that's 4 times 1.01 plus 12.01 for carbon. That's 16.05 grams per mole. And so we can cross out grams, and we get 5.5 divided by that 16.05 there. And we get 0.3426799127 moles of CH4. And so now we can use a mole ratio. It's a 1 CH4 to 1 CO2 ratio. So since it's 1 to 1, we can say, therefore, the moles of CO2 is equal to the moles of CH4. And so that's going to give us this number over here, which I can put here, 0.342679 moles. I didn't write all the digits down. You don't have to, but keep as many as you can in your calculator, so that way you don't round too early. And so let's go ahead and do that. Step 4. We can do that the volume is equal to that mole value there, 0.346679 moles, times the R, 8.314 kPa liters, kilopascals liters, over mole Kelvin, times the temperature, which was 308.15 Kelvin, over the pressure, which is 100 kilopascals. We can cross out the pressure units. We can cross out the mole units because it's mole over mole there. We can cross out the Kelvin units because it's Kelvin over Kelvin. And we're left with the liters. And so that's going to be equal to, so times 8.314 times 308.15 divided by 100. And we get 8.7792999097 moles, or not moles, but we're at liters now for volume, liters of CO2. And so we have to write our therefore statement with the appropriate number of sig figs. So therefore the volume is approximately, looks like we have 1 sig fig. So 1 significant figure. We can round this up to 9. Approximately 9 liters of CO2. So again, we wrote a balanced equation out, as you can see over here. We wrote down all the information that we had. We wanted to find the volume of CO2. It's a gas, so I know I'm going to use my ideal gas law to find the volume using the rearrangement of the ideal gas law, so nRT over P. I need the moles, though, so I had everything given to me in the question except for moles. So what I had is one of the reactants. I had the mass given to me, and so I could use that mass divided by the molar mass to find the moles of that compound. I then did a ratio for the moles of CH4 to moles of CO2 in the equation, as you can see over here. So it was 1 to 1. So here's the ratio over here. And since it was 1 to 1, the moles of CO2 is going to be equal to the moles of CH4 that we calculated. And then we can plug that mole into the initial equation we wrote over here, which I did over here. And then we got our final value of CO2 for the volume. And then we made sure we rounded to the correct number of sig figs, which is 1, because in the question, the pressure was given to us as 100 kPa, no decimal there. So it was 1 sig fig as the smallest value. And so that's 9 liters of CO2. And just remember that throughout, you don't want to round too early, otherwise you're farther away from your answer than you should be. So keep as many decimal places as you can in your calculator, and then do that final rounding at the end. And so that's stoichiometry with the ideal gas law. And at this point in the course, you've seen stoichiometry with a variety of different paths that you can take using the main formulas we discussed throughout the course.